This is a demonstration of TSI static voltage regulator technology. As you are all aware, electronics is rapidly replacing electrical devices in factories, offices, malls, and residences, be it robotics, CNC, automation, and drives in factories, IT, HVAC, elevators, projection and lighting systems in offices and malls, sophisticated TV and sound systems, inverter air conditioners, inverter machines, LED lightings, and home automation systems in residences. The foremost demand of electronics is high quality of power, where any sudden voltage fluctuations, surges, sags are controlled within one waveform, that is, 20 milliseconds or 1/50th part of a second. This is easier said than done by conventional technologies of servo voltage stabilizers or tap-changing transformers, because these may take anywhere from half second to several seconds depending on severity of voltage defect. The ideal solution is a static voltage regulator which has the capability to instantaneously correct all kinds of voltage defects, including the very harmful sags. Let us now witness a comparison of a typical servo voltage stabilizer with our TSI VRP static voltage regulator at a simple demonstration setup created in our factory at Vadodara in India. Here is a sag surge generator which supplies a nominal 230 volts to a static voltage regulator and also the same 230 volts to a servo voltage stabilizer. Both the servo voltage stabilizer as well as the static voltage regulator are designed to provide a stabilized output at 230 volts plus minus 1%. The sag surge generator can be switched on and off by this switch to generate either a sag of 20% magnitude or a surge of 20% magnitude. Accordingly, the input voltage to both the static voltage regulator as well as the servo voltage stabilizer will either suddenly fall by 20% or suddenly rise by 20%. To monitor the resultant performance, there is an oscilloscope with 3 channels. As you can see here, this yellow top channel records the voltage waveform generated by the sag surge generator. This channel is marked as input waveform to both the servo and the static voltage regulator. This waveform is then corrected by the static voltage regulator, whose output is recorded in this channel marked as VRP. This waveform is simultaneously also corrected by the servo voltage stabilizer, whose output is recorded in this channel, marked as servo. We are now ready to observe a sag phenomenon. So, let's generate a short sag. As you can clearly see, a sag occurred on the input side of both the equipment, and both the equipment behaved very differently. The static voltage regulator corrected the sag within a single waveform of 20 milliseconds. But the servo voltage stabilizer took a very long time to correct. Furthermore, in the case of servo voltage stabilizer, as soon as the sag disappeared, servo stabilizer gave a high voltage output because it was still in its boost mode. If this output high voltage was beyond the cutoff limit, then servo voltage stabilizer would trip. But nothing of this sort happened in the case of static voltage regulator. You will observe from its waveform that it corrected everything within one waveform or within 20 milliseconds. Let's now observe a surge phenomenon. We will create a short duration surge of 20% magnitude and see the results. You can observe here, the topmost waveform is the input to the equipment, and this waveform clearly shows a surge. The second waveform is the output of the static voltage regulator, VRP, and you can observe the surge was corrected instantaneously. Whereas the third waveform is the output of the servo voltage stabilizer, where you will see that the surge was corrected slowly, and when the surge disappeared once again, the voltage was corrected back to its original value. So, as we can observe, the static voltage regulator would correct a surge or sag instantaneously, while servo voltage stabilizer would keep struggling. So, we conclude that the static voltage regulator is a complete power conditioner, which controls all kinds of voltage fluctuations, surges, and sags, all within 20 milliseconds, that is, one waveform. In addition, it also has a built-in noise control filter. This perfect technology is made available to you by TSI Power, based at Vadodara in India. For more queries or questions, you may write to us at info@tsipower.in. or visit our website www.tsipower.in. Thanks for watching.